Hello everyone, welcome to Cloud World. On today's video, we are going to be working on the second piece, which is going to be the Skillsets for the Azure AI service. So let's take a look into the summary what we are going to be doing today and what are the most important skillsets that are available on the Azure side for the AI search. So we are going to be working with the different skillsets available for the Azure AI service. So as a quick reminder, the skillsets are like a pipeline. You can select one or multiple tasks that are going to be working against your data source, and it will be making pre-processing and processing into that data. As an example, these actions could be things like OCR, language detection, entity detection, computer vision detection, PI detection, sentiment analysis, text translation, and many others that are actually available by default and you can easily use throughout your code. The most important piece to mention is that we can call this a pipeline because we can use multiple of those and connect the input and the output from one into the other. This is not only going to provide more cleaner outputs but also more specialized, and is going to allow your Azure Search AI to produce more equally results and in huge quality. So with that in mind, let's take a look at what we are going to be doing in today's lab, and we are going to be following these steps in order to implement a skill set pipeline. So for today's lab, we are going to be including a couple of the different skill sets that are already available. So let's take a look. We are going to have a couple of inputs in the different pipeline that we are going to be building for. So that will be the OCR, the merge operation, key phrase, language detection, and split skill, and also the entity recognition. So if we remember from the Azure portal, we have something like this. We have three different files, which is a data.json, an image of explaining what is RAG, and a PDF, which is what is AI. Remember that you can add multiple files in here in different formats, and with the pipelines that we are going to be building today, the pre-processing is actually going to be very simple. If we take a sneak peek into the data.json, we are going to be seeing that the information that is being contained into the JSON is just a title and a value. The title just contains a random title, and the value is something related to machine learning, AI, and different topics. Something pretty simple. From the image, we have a screenshot from the NVIDIA source explaining what is RAG. And this is actually going to be pretty useful for the OCR. Also, in addition to that, we are going to be working with a free PDF, which just explains what is AI. And this document contains 12 pages. So as you can see, it has images, also contains different types of text. So this is going to be very handy and the example that we are going to be working to. Now let's start working with the first part. So the first input that we are going to be working as the skill set, it will be the OCR. The OCR is the object character recognition, and this is a very popular computer vision technique which actually analyzes an image and extract any text from it. So if we take a sneak peek, when we process the OCR, the process is going to be automatically picking up this image that we are seeing on screen, and is going to extract all the visible text from it. So it is important to mention for all the steps that we have also this pinkish block, and this pinkish block for all the steps are going to be inputs. The yellow ones are going to be outputs. So the OCR skill set is going to take all the images that are located in the document folder. As a quick reminder, when we are working with the skill sets, all the files that are part of your data source will be located by default in the document folder. From here, we can take the input as things like document, normalize images, which is the data extraction initially that is done to image, and all the images are going to be put into this folder. So the OCR is going to take this folder as an input and is going to process anything located into the document folder and extract the text using the computer vision technique. After that, the result will be written into a text folder, which remember is also part of the document. So the real party will be document/text. Pretty simple. So after that, the result will be sent into another skill set, which is the merge. So let's take a look what this is going to do. Merge is going to take three inputs. It's going to take the document content, it's going to be taking the normalized images text, and also the content offset. All of these folders are previously generated by the OCR step, and this one is being generated by the another step that we will see in a moment. What this merge operation is going to do is that it's going to take up all the results present into these images from the text, and it's going to merge everything together and send the result into a merge text folder. Before taking a look into the key phrase, let's take a look into another step, which is going to be the language detection. This skill set, as the name said, is going to analyze some of the text into the merged text document folder, and is going to provide an output, which is the language code. In this case, this is a property that is fully usable in other places. So now that we have the language code output will be sent to the key phrase together with the merged text. And this skill set, what it's going to do using the language code and the merged text, is going to extract key phrases from the content. It is pretty important to have the language code in here, because the key phrase plus with the text with the language code is going to allow this process to extract successfully the quotes and the most common phrases throughout the document, trying to find the main idea. From there, the output is going to be written into a text items folder and also into the pages one. So this thing makes things pretty simple. So at the end, the document folder is going to contain a subfolder named pages, which is going to contain the result of all display processing, OCR, merge, and key phrase extraction. If we go into the right, also from the language code detection, we are making an additional conversion in here, which is the split skill. The split skill, what it actually is going to do, is going to take a huge amount of data, especially of course in this case text, and is going to split everything into a smaller text or even pages. That will depend on the configuration that you give. So if you provide a limit of length, it's going to split the text into smaller sentences, and if you provide a pages, it's going to create pages based on that site. The split skill also depends on the language code, which is going to be used also to work properly to split the documents. Once this has been completed, this is going to be written into the pages document, into the pages under the document folder, and the output from this is going to be sent into another skill set, which is going to be the entity recognition. The entity recognition is actually pretty handy, because this is going to take the input from the previous document into smaller pages, and is going to extract important information. The entity recognition can take inputs as categories, default language code, and the minimum precision the model version as part of the inputs. So in this case, the input that we are sending to this one, it will be the different documents that we have pre-processed previously, and we can extract anything from it. The most important part, it will be the categories, because on that array of collection, we can specify which type of object we would like to extract. For example, we can detect into the text entities like persons, location, person types, email, URLs, addresses, phone numbers, and other ones. So in this tutorial example, we are going to be extracting any organization just as an example, but you can extract any of the ones that I previously mentioned and get all the information. At the end, all this information is going to be stored into the skill set once the pipeline has been executed. But that will be part of the indexer, what we are going to be doing in the next video, where we are going to be building the indexer to execute the skill set pipeline, and also work it together with the index in order to expose the result. So with all the theory in hand, so let's take a look into the code. So now with the skill sets are ready to open, as the previous video, I created some boilerplate, which actually makes things pretty simple. This is going to be a handler again, and it's going to contain the basic code. So in order to create the skill sets, as I mentioned before, we need to build all the skills individually, and then we can connect them together when we create the final skill set. So for the first part of the video, we are going to be creating fully manually the OCR and the merge skill, so to take as an example. Then I will include all the other skills. We will take a quick navigation into those and into the final output where we are going to be building the skill sets. So let's start with the OCR. The first thing that we need to provide, as I mentioned, into the skill set, it will be the inputs and outputs. So let's start with that. In order to create the inputs, we just need to provide a list, and in this case, the parameter that we are going to be using will be the input field mapping entry. So let's map these input mappings, OCR in here, and let's create our array in here. So as part of the definition, we need to provide the name of the input and also the source of the input. So if we remember for the OCR, we are going to be providing a new item in here, which is going to be the image extraction, and the source of this item is going to be the location into the document folder, normalize images, and star. So this is going to pick up all the images that are located under the document folder. Now let's define the output, which is actually pretty similar. It will be also a list, but in this case it's going to be an output field map entry. So let's define the output mappings OCR. And also let's create a new output for this one. So the case on this one, we said that we are going to be naming this one text, and the target name for the output, it will be also the text folder. So when the OCR execute is going to take all the files located into this folder, which is actually automatically being generated by the data source when operating together with the skill sets and the indexer, and is going to write the output of the preprocessing into the text folder. So we have our inputs and our outputs. So now what we have to do is to create the OCR skill. So in order to create that, let's use a new instance of the OCR skill. And this is going to take a couple of things. The first thing, it will be the input mapping and the output mapping. But also, as an additional information, we can provide information like the context, the description, and other things. So for the description, let's say that we are going to extract text from images on the data source. On the second parameter, we need to provide the most important one. It is going to be the context of execution. In this case, the context, it will be document, normalize images, and star. So the context of the execution will be the initial folder where the OCR skill is going to be working on. So this is going to locate the skill under the default folder, and is going to work with the information located under it. Also, we can provide the default language code. In this case, we are going to be using the OCR skill language. In this case, will be providing the language N. An important thing in here is that I could execute also the language skill in order to extract the language and send it in here. But for the initial basic example, let's use all the default English, which is the text, the default language for the text that we have on the data source. And let's set up a show detect orientation, which is going to analyze the image and detect the orientation of the text. And it's going to take a look if this is a read, a right, or a left reading. So now we have created the first part with the OCR. So we work with the normalized images, we save the output into a text folder, and now let's build together the merge one. So for this one, we are going to have three inputs: the text, items to insert, and the offsets. These three definitions are part of the merge operation, and we are going to be taking the input from the text for the document content, which is the one that is going to store the document. The items to insert, it will be part of the image that we extracted previously into the text folder, and also as part of the content offset that is also created by the OCR. Once we have everything together, we are going to be merging the text and serving this text into the merge text folder. So let's go back into the code and build the merge skill set. So as the previous step, let's provide the first thing, our inputs. So for the input mappings of the merge, we have the text, items to insert, and also the offset that we display on the diagrams. So this is going to be targeted document content, the images normalized, and also normalized images into the content offset. For the output, we are going to be saving everything into the merge text, as we said. So the output mapping, it will be merge text, and we are going to be saving that into the target text. So for the merge skill, what we need to create is a merge skill operation, which is actually pretty similar. So we provide the inputs and outputs for the merge skill. We provide a description, the context of execution as we did on the previous step. We can use a pre-tag, a post-tag in case we want to, but this is not required in this case, so we are just going to be leaving it as an empty item. These two, what are actually going to provide us, it will be for the insert pre-tag, it will be a string that can be included before every insertion into the text. And the post tag is quite the contrary. Instead of going at the beginning of the insertion, it can go into the end. The default option is actually an empty string, but in this case we are using a space in order to separate the output from the merge text. So now let's take a look into the language detection skill, and let's build that one. So for the language detection, as we said, we are going to be taking the input from the document merge text, and we are going to be creating an output, which is going to be the language code. After that, we are going to be working on the split skill and also into the key phrase extraction skill set in order to work with the language code. So let's take a look into the language detection. As in the previous two cases, we have to provide inputs and outputs. So the input in this case for the language code, it will be the document merge text. This is going to be the support text that the language detection skill set is going to use in order to detect the predominant language into the components. For the output, we are going to be providing the output into the language code. Now what we have to do is, as the previous step, is also to build the detection skill for the language code. So as previously, this takes the input mappings, the output mappings, a description, and the context where the result is going to be saved. In this case, the result for the language skill is going to be saved into the route folder. Now let's take a look into the split skill set. So for that, we are going to be taking two inputs, the document merge text and also the language code. When the split skill operation works, it's going to be saving the result into the pages on the document folders. So the text split is going to break our text into smaller chunks, because if you remember, as an example, the PDF, it was actually a little bit long, 12 pages. So that might be an overkill in order to search inside that information. So what we are going to do with the split skill is to split that particular text into smaller chunks for any document that could be present into the storage account. So this is going to split everything into different pages into a size that we are going to be providing. So for the maximum page length, we are going to be using 4,000 characters in our example. And we are going to be using the English language in order to extract everything. And for the split mode, we will be using pages to extract the information. So let's take a look into the code. So as the previous examples, we also need to provide, of course, inputs and outputs. So we are having two inputs and one output. So for the input, as I said, we are taking everything from the text and from the language code. And for the outputs, we are going to be saving everything into the text pages. So for the split skill, this actually is also pretty simple to configure. We need to provide the inputs and outputs as the initial parameters for the split skill. We'll provide a description. The context in this case, it will be the document folder. And for the split mode, we are going to be using pages. Like I said, we can split the content into pages or sentences based on our requirement. In this case, we are going to be creating pages that are going to be a maximum length of 4,000 characters. And for the default language code, we are going to be using English. But also remember that we are passing the language code as an input, so that is going to be predominant in this case, in case our documents are located in a different language that is not English. Now with the skill set already set into the split mode, we can go back into the next step, which is going to be the entity recognition. So we are going to be taking one input from the document pages that have been extracted on the previous step in here. And we are going to be extracting a couple of entities, in this case, the organization. So let's go back into the code, where, as always, we are going to be providing inputs, outputs, and setting up the required class to do the entity recognition. So for the inputs, we are going to be taking the content text, and we are going to be scanning the document pages and all the subfolders into it. And for the output mapping, we are going to be mapping the organization as part of the entity requirement. Remember that the entity recognition can do things like organization, person, location, and many others. So if I wanted to extract all the information for the entity recognition, I could include those in here. For today's example, let's keep it as an organization, but we are going to be extending this later just to provide more qualified example on how to use the output for the entity mapping. For the skill, as always, it's pretty easy to build. We just need to provide a couple of things: the inputs, the outputs, and this one is pretty important. The skill version for the entity recognition has already multiple versions, and the one that is acting fully available today, it will be V3. So remember to specify this in here. Otherwise, it will go with an older version, and once we make a request throughout the SDK, it's going to reject it. This is pretty important. So the description and the context is pretty safe already. And the default code language, we are going to be using English in this case. So now with the entity recognition at hand, let's move into the next step, which is going to be the key phrase skill. So for the key phrase extraction, we will be taking the text into the document integrated merge, and we are going to be taking also the language code, and we are going to be saving the output of that code into the pages folder. So let's take a look into the implementation for the code. Once more, we need to provide inputs and outputs for our code. So for the key phrase extraction, we have the text, and this is going to be scanning the document page start folder. And for the key phrases output, we are going to be saving everything into key phrases. For the skill set, it's pretty similar as well. We provide the key phrase extraction skill, provide inputs and outputs for it, the description and the context, and the default language that we are going to be working on. So with this, we have all the skill set that we explained about it. So the final part, it will be to build the indexed skill set, or maybe as you could call it, the pipeline, in order to integrate all of these together. So in order to build the skill search indexer, what we are going to be using will be the search indexer skillset class, and we are going to provide a couple of things. The first parameter will be the name of the skill set, how we would like to create it. The second parameter will be the list of skill sets that we would like to merge. As you can see, I am providing all of the skill sets that we already created so far. Remember, the order is very important, especially when a skill set has dependency on the other one. That is going to matter. So as you remember, the OCR skill generates an output, and the merge skill is going to be taking advantage of those. So the OCR needs to go first. Or the language detection is going to be fed into the split skill and also into the key phrase extraction and the entity recognition. So it needs to go first. Also, the key phrase extraction needs to work together with the split skill and the entity recognition. So take a look into the order. So for that, we only need to provide a description. Now, using once more the indexer client and the Azure factory injected throughout the class, we can get access to the client. So the final part, it will be to make a request into the endpoint to create the indexer. So for that, we will be using again the search indexer client, and the method that we are going to be using, it will be the create or update a skillset async. So this is going to take the input from the pipeline that we just defined and the cancellation token too. This is going to hold the response, so we are going to get a grab on the response. And using the response, we are going to be writing the output for the message that we are creating throughout the handler. So from the response, we are going to be taking the name and also the description. This is going to give us a very quick summary and overview that the process has been completed successfully. So now we have built our pipeline. So let's take a look into the executed endpoint and let's create the skill set. Then let's execute our code and let's go back into the browser. With the new skillset endpoint, let's provide just a basic input in here. The name of the skillset is going to be data skillset, and the description is going to be a skillset to process blob storage data. Let's execute this endpoint. This should be very quickly. This doesn't take too much. Okay, we got the response properly. So let's take a sneak peek into the Azure portal. So previously we didn't have any skill sets, and now we have our new skill set that has been just created. As you can see, this skill set pipeline is composed of 6 different skills that we already defined. If we take a look into this one, we are going to be finding the JSON description for it, and we will find the different types. So we have the skills. As an example, we have the OCR, we have the merge skills, we have the language detection, and all the other ones. You can also build these kind of things using the JSON expressions. That's up to you, and you can make that kind of things using the REST API. So for now, we will be using the SDK. In future videos, we will be using a different model, which is going to be the REST API, in order to interact with the resources, so we can learn all the activity tools that we have in order to comply with this. So far, we only created the skill set, but let's get together in the next video, because we are going to be building the indexer. And the indexer is going to work together with the index, which we are also going to be creating on the next video. And the indexer is going to connect everything. The skill set, the index, and also the data source that we already created to execute the full pipeline. The indexer is going to produce the output information that we can query throughout the index. I hope you like this video, so see you in the next one. Have a good one.